Hi, this is Jay Chitra Chepa. I'm going to talk about effective research-based analysis on peer-to-peer security. The analysis are focused on four different things. The first one we are going to see is how the peer-to-peer network architecture works, how it actually differs from the traditional network with a central server. The second point we are going to talk about is what and all the basic operation involved in the peer-to-peer network layer. The third thing will it it will list all the possible attacks which has been encountered in the peer-to-peer layer of network, and the research-based possible solution proposed has been followed. Finally, the summary of the overall presentation will be there. Let's look into how peer-to-peer network differs from the traditional network. Let's look into the architecture. In the left hand side, you can see the example of a client-based network architecture or the traditional network architecture. Here, the users are connected to the server, and the server is the one which is responsible for holding all the information, and the server will determine who can get the access to the files on the network. Here, the server will authenticate the user and do all the major operations. The client was not supposed to do any of the operation apart from giving their information to validate their information. In case of peer-to-peer network, as you can see, the architecture is completely different when compared to the traditional network. And you can clearly see there is no server in the peer-to-peer network. In peer-to-peer network, every computer will act as nodes. Each node will connect with the other nodes in the network, and it forms a overall layer of peer-to-peer network. Here, the peer will act as both client and server. Therefore, it will get request from the other peers, and it will also process the request of the other peers. Let's look into the basic operations of peer-to-peer network. Join. The security domain administrator will authenticate a new peer to join into the network. Once the peer joins the network, it can start communicate and share resources with each other. Here, there are two peers are there, active peer and a passive peer. The active peer is the one who holds a public IP address, and it can store some part of the resources, and it will have some list of passive peers which it can send the query from the passive peers to the overall layer of the network. The passive peer who doesn't have an public IP address in the network. The passive peer will spread the communication with the help of an active peer. Leave. A peer has the option to leave the peer-to-peer network services by using the leave operation without informing domain administrator. Search. Whenever a peer starts a query search in the peer-to-peer network, the other peer who are able to receive search query can respond to it. Only an authenticated peer can send the peer query through the overall layer of the network. As I said earlier, the passive peer, whenever wants to search a query, it will send it to the query will reach to the surrounding peers at a definite distance. So whenever the query is not successful, like the peer doesn't get the targeted file, the active peer will send the query to the overall layer of the network to receive a response. Chat. Any peer from the group can select any other peer for communication, as they can send or receive text or voice messages from each other. Routing. The security domain administrator should be able to define and implement a routing mechanism so that only authenticated user can join the network. Insertion and retrieval. Here, whenever a peer has joined a network, the hash value for the peer will be generated and inserted into the routing table. And then, same way, any available peer's hash value will be available for the other peer from the routing table. Update and delete. An authenticated peer can change the contents of inserted resource, and it also can delete the information. Multicasting. Peers on the middle can able to relay the multicasting packets to the nearby peers. Only an authenticated peer can be able to perform in this operation. Let's look into the positive sides of peer-to-peer growth. We all know peer-to-peer growth is enormous nowadays. Let's look into the merits. No strain on server. In case of a traditional network, the server will carry all the desired information for the user to access. But in case of peer-to-peer network, each peer which is participating in the peer-to-peer network has to share the resources, so it avoids the strain on the server. Ideal environment. It promises an ideal environment to share massive file sizes or folders between the other peers, free of the fear of overloading the one. No single point of failure. When the server breaks down in the traditional network, user won't be able to access any files on the network. In peer-to-peer, if one of the peer is not able to deliver the service, the other peer can replace it. For instance, if a peer wants to download a desired file from the neighbor peer, in case of the peer can't deliver the targeted file, the peer who wants the file can again do a search query. From the search query, it can be able to locate the other peer who has the same file, and from that peer, the peer can download it. But in case of a traditional network, if the user wants to get the file from the server, in case of server breakdown, the user won't be able to get the file in a short period of time until the server works fine. Final one is it is much easier and less expensive to set up, as it doesn't require a central server or workstation to process all the functions and everything. It will require less manpower just to work in the central station, and it will be very less expensive to set up. Let's not neglect the darker side. The major disadvantage of the peer-to-peer network are it gives a chance for the malicious content to be shared and spread easily within the network as the peers are connected with each other. No centralized backup. Backup has to be performed on each computer separately. This is because all the peers in the peer-to-peer network as resources, backup needs to be performed on each peer separately in a regular basis. Make each one secure. Since all the peer in the network carries the essential information, each peer needs to be secured by using antivirus software or any kind of secure mechanism to make sure the malicious content is not within the system. Besides, there is a lot of security, privacy, and identity issues evolved around the peer-to-peer network. Approaches to secure peer-to-peer networks. There are two main approaches, encryption and anonymity. Encryption. If your peer-to-peer data stream is encrypted, it cannot be detected easily, so attacks will be blocked. Anonymity. It can protect the identity of the nodes and users on the network. An anonymous peer-to-peer network provides enough anonymity such that it is extremely difficult to find the source or destination of a data stream. Let's look into the possible security factors which can be applied to the peer-to-peer network in order to make it more secure. There are 6 secure factors have been proposed. The first one and the most important one is the user authentication. It enables to verify the authentication of the peer. It is kind of very hard to deploy in the peer-to-peer network than the traditional network, as there is no central server to authenticate the person. For this situation, peer-to-peer uses 2 separate keys to authenticate the user. The next one is the availability. Data should be available to the authorized user when he wants to access into it. The next one is usability. The interface should be user-friendly so that it is easily understandable and he can change the settings according to their preference. Privacy protection. Anonymity is a feature in which the identity is not revealed. Access control. Access control is the mechanism and policies that restricts access to computer resources in a process. Data integrity. It ensures that data is not changed, destroyed, or lost in an unauthorized manner. Let's look into the possible attacks. There are 3 different types of attacks. Attacks on peer-to-peer network, attacks realized through peer-to-peer network, attacks on users of peer-to-peer network. Attacks on peer-to-peer network consist of listening queries, leeches. Attacks realized through peer-to-peer network consist of DDoS attack, malware spreading, poisoning of network. Attacks on users of peer-to-peer are content verification and stealing identity. Listening queries. This attack utilizes open architecture of Gnutella network. Gnutella is one of the popular peer-to-peer application which has the open architecture. In Gnutella network, interconnecting nodes are able to see the significant part of queries from all servers in the local subgraph. Let's look into how much damage it can cause if it behaves badly. Each supernode can see a crucial amount of communication whatever takes place inside the subgraph. In case of Gnutella, it uses a 7-jump searching protocol, so every query goes through the whole network via 6 supernodes. If each supernode know about 4 other supernodes, then it's possible for 1300 supernodes to see this query. In case of compromising a node which is able to eavesdrop the amount of queries will bring down the anonymity of Gnutella users. There are 3 methods which has been proposed in order to defend the anonymity in peer-to-peer networks. The first one is tunneling. It makes use of the intermediate nodes to make a separate path between the sender and receiver, that is the sender peer to the targeted peer. Many methods use tunneling to provide anonymity for their applications. The next one is broadcast encryption. It is the process of delivering encrypted data in the network. Once the data goes away from the sender, it will get encrypted so that whenever a query is made, whenever a file is transferred, the other peer in the networks won't be able to decrypt the data. Only a valid user from the network can be able to decrypt it. A friend-to-friend enables peer-to-peer make direct connection with the desired peer. passwords, or digital signature can be used for the authentication purpose. The next one we are going to see is the leeches. It is the reason for imbalance. Leeches are peer-to-peer network clients who don't utilize administration for document sharing and it just downloads the information. They won't share any identity with the peer-to-peer network like the active peers involved in the network. These users contribute to an imbalance in the most peer-to-peer network where a small percentage of users bear the majority of the sharing load. It happens in a case if if there is any less number of active peers and more number of passive peers are there, only less number of active peers are available to have the resources shared between them. A computer can't have more than some amount of data. It's not a big workstation to a central server or station to hold so much of amount of data, since it creates the imbalance in the network. If there is more active peers in the network, it will give an healthy peer-to-peer network. Having an imbalance creates an inefficient work with a presumably slower transfer speeds than what could be possible. To overcome this, administration of document sharing will be more helpful. A standard tool for administrating the document sharing process will be a promising solution to know which peer got which file. Content verification. The information what each peer is receiving in this network needs to be validated. Validity checking of downloaded document. Each time we download a record, we should guarantee that substance of document relates to the proposed record. That is, whenever a peer asks for a file from a targeted peer, after that the targeted peer will send the desired file to the peer. In the way, there are several peers in between them. So whenever a file is transferred, there is more chances for the other peer to get it and transfer the content. So data integrity is very essential in place of content verification. So in case of this kind of things, digital signature can be used. Malicious downloads can be very dangerous sometimes and can lead to distortion of the peer situation. As I said earlier, digital signature is a mathematical technique used to validate the authenticity and integrity of a message. So whenever a sender sends a file, he will provide a digital signature along with the document, one and he will logs with a public key, private key, and then he will send the document to the desired peer, and he will share the public key to the receiver. The receiver, with the help of the public key, will open the document, and so that he will understood the integrity of the document will be good and it's not modified while it came across through the peer. Stealing identity or data. Peer-to-peer PCs and records could be attacked by advanced users, for the most part by visit administration of peer-to-peer clients. Attackers can abuse requests of these beginning users for an assistance to get sensitive information. They have so much of tools in the world, that is like monitoring tools monitor. It will check the mails, files, online banking and other case sensitive information, and they can steal the information from the network. This situation can be overcome by allowing only authenticated user can see the sensitive information. But if in case of an authenticated peer behaves badly, this could be considered one serious issue. DDoS attack. The distributed denial of service attack. The main goal of this attack is to exhaust victims' resources. In DDoS attack, there are two types of distributed denial of service attack: TCP connection distributed denial of service attack and bandwidth attack. In TCP connection DDoS attack, it will exhaust the service by fully open TCP connections. Bandwidth attack. This attack will be done by sending huge amount of packets to overload target's bandwidth. It can be carried out by index poisoning or route table poisoning. Index poisoning. Attacker will insert the fake record into the peer-to-peer network. In route table poisoning, attacker will insert the fake record into the routing table of the peer-to-peer network. In index poisoning, the attacker will insert the fake record which actually passes through the network, and whoever gets it downloaded, their system will be corrupted. But in route table poisoning, what actually the peer will do is the attacker will insert the fake record in the routing table, and he will act as a trusting peer, and he will contact the neighboring peer, and he will attack the neighboring peer resources and make the neighboring peer unavailable. This is what the attacker will do in case of route table poisoning. Attack stimulation. Based on the research work carried by Schaffer and Malginica et al., a network of 20 virtual computers were connected to a peer-to-peer network, Direct Connect++, for this attack stimulation with DC++ hub. Direct Connect++ is a peer-to-peer application, and it has an open source architecture. The ratio of the active node to passive node is 20:80. As I said earlier, the active node is the node with public IP address, and passive node is the node without public IP address. In that, active node will hold the resources in the peer-to-peer network. The stimulated queries attack by making the peer to do automatic download of non-existing file provided by the target client. This was achieved by deleting the shared file. Here, they made the group of clients in the Direct Connect+ network to send request for the non-existing file to the targeted peer. The targeted peer has responded to this query by providing the non-existing file error message. Findings. Based on the research carried out, DDoS attack might be unsuccessful in a smaller peer-to-peer network settings. In case of a successful attack in the larger settings, it will lead to a condition of no one can get any other files from the target client. It might also result in the denial of service file sharing between the target client and the other peers in the network. Due to the consistent failure of the targeted peer, when a peer wants to acquire a data, there is a higher probability of a target peer removal from the network. Malware. Spreading faster. A significant number of botnet attacks can be joined with malware for instant content verification with assault utilizing malware. Research work. An empirical model was proposed by Schaffer and Malginica et al. To implement the detection systems and precautionary measures. Models in the proposed system. Models for the proposed system, there are 5 models in that. Model for correspondence with peer-to-peer system, model for download and pursuit definition, model for infection examination, model for correspondent examination, model for looking after correspondence between different models. Methodology. The proposed system for automatic file downloading from peer-to-peer networks, as it helps to download and analyze the files available in the peer-to-peer network. The proposed system works in a way when someone runs into some infected file while downloading a file in peer-to-peer network, the system will notice and it will start a full analysis of this file and spreads the targeted file metadata through all connected peer-to-peer networks to find out the diffusion level in the network. and then the system does this diffuse analysis regularly. This approach provides details regarding the number of files spreading, number of users involved, and duration of the file in the infected user's computer. They didn't possess enough. This system looks fine, but they never tested in a real-time situation. It needs to be tested in a real-time situation to see the validity of these results. There are other ways in order to come over the malware problem. Trust management scheme. There are several trust management schemes which are proposed to lessen the degree of reducing the peer getting infected by downloading malicious content files. Purpose. Based on primarily of peer trust value. Here they will generate a trust value for the peer and a file reputation value, and it also uses infectious value. Based on this, like if the trust value is higher and the infectious value is lower, it enables the user to understand there is a less probability of getting a malware into the system. There are existing models which helps this purpose are dynamic trust management scheme, double layer dynamic trust management scheme, 3D trust management scheme. Poisoning network. As the name implies, infusing pointless information into the network. Fake things could hinder query times and also yield invalid results. Poisoning can also be fodder for DDoS attack. This can be done in two ways, namely index poisoning or root table poisoning. As we saw this explanation for this, the protocol is Reliable Index Exchange Protocol was proposed as it helps peer accountability. Wang et al. Tested the RIAP defense in a peer-to-peer network over 1 million nodes and found out the effectiveness of this model. It proves RIAP-enabled peers cannot launch index poisoning attacks on unauthorized IP address. It also identifies peers who are attempting to launch the attacks. Each file index can be tracked back to the publishing host without user authentication. RIAP effectively reduces the attack traffic towards the targeted victim. Okay, let's look into the summary of the overall presentation. In this presentation, we have seen how peer-to-peer network operates in the real-time situation. Its architecture has been clearly discussed. Peer-to-peer network is a distributed application architecture which partitions tasks or workloads between peers. Here, the attacks have been categorized into three types: attacks on peer-to-peer network, attacks realized through peer-to-peer networks, attacks on users of peer-to-peer network. The attacks that has been encountered in the peer-to-peer network has been clearly addressed with all the possible research-based solutions. And then we also saw the secure network approaches. And also there are some secure peer-to-peer network operations have been suggested in order to make the network more secure. The accumulation of result will pave a way for new questions related to the privacy of peer-to-peer network users. This work gives a way to implement the solutions in a real-time peer-to-peer network settings to analyze the validity of the results in the future. As we saw earlier, all these results are not tested in a real-time situation. So if this result are tested in a real-time situation, it provides the validity of these results. I want to thank you, sir, for this opportunity provided for me to go around this topic and be able to find out the different attacks and come up with the possible solutions. As I am always had a passion towards the network security, I want to replicate the same paper findings in a real-time situation to validate the results. Thank you.